Chuck, I think it's about time we talked about heat waves.
Well, yeah. I mean,
Actually, wasn't that a disco group in the 70s?
it
Heatwave?
was. Heatwave was the name of a group. Yes, yes.
They did the soundtrack to what's that movie? To Car Wash. I think their song is "I Want to Get Next to You."
No, that's Rolls Royce.
Oh, Rolls Royce. Oh, damn.
Yes, yes.
Damn.
But
Damn, don't out 1970s me. How you do that? How you do that?
oh, I mean, believe it or not, my daughter listens to that music.
Anyhow,
Yeah.
so just thought we'd talk about heat waves. And I have, other than being familiar with the group that I didn't properly identify from the 70s, I have no expertise in this, but we are in New York City.
Right.
And right up the block from the American Museum of Natural History is the Goddard Institute for Space Studies, one of 10 NASA centers scattered across the country. And we have the director of the Goddard Institute for Space Studies.
Head honcho?
The man about town himself,
Yeah.
Gavin Schmidt. Gavin, welcome back to StarTalk.
Hi, Neil. How are you? Yeah, nice to be back.
Excellent, excellent. And what many people don't know is what that NASA center specializes in. Just give me like the one sentence sort of specialty case for it.
Climate. Climate change, climate feedbacks, climate responses, climate observations, climate impacts. The whole kit and
Of all
caboodle.
planets.
Well, mostly this planet, but also exoplanets,
Mostly.
and also the climate of Mars, the climate of Venus. Back, 3 billion years ago, we've been working on all of those things.
Well, I'm glad we made it on your list, Gavin.
That Earth is on the
Yeah,
list.
I'm happy to see that Earth is in the running there.
Yeah, well, people don't think that NASA really cares about the Earth, but actually, we spend more than $2 billion a year looking at the Earth and trying to understand what's going on. And so we actually are one of the lead agencies around the world trying to work out what is happening and why.
Oh, and by the way, and Gavin, you don't have to comment on this, but during one of my tours of duty in Washington, there were forces operating to prevent NASA from studying Earth, saying NASA should just worry about space. And I was on a commission to deal with this, and I said, you can't claim to understand Earth unless we know how it fits in the context of other planets and in the space environment. And so I think I won that fight because Gavin still has a job. I'm thinking about with NASA.
You were eloquent in your defense. However, it's a much simpler answer. I'm not sure if you know this, but Earth is in space.
Yes, Earth is in space, completely in space.
Yeah.
But that was an early push to remove the government from its efforts to aid and abet the data that was discovering climate change.
And who did it? Exxon.
On Earth. No, stop.
Once
So let's get back to this.
Right.
So, Gavin, what is a heat wave? I think we know a heat wave. Well, in New York City, a heat wave is some number of days where the high goes above 90. All right, we're on Fahrenheit world here, and of course, I lived in Texas for a while. And
That's every day. Yeah.
That's every day, right? So a heat wave was like over something else. So heat wave seems to be very locally defined. And does that have any meaning to you as a climate professional?
Yeah, so it's an interesting thing. So a lot of why we care about heat waves is not because of the absolute temperature, but because of the difference from what we're prepared for. Right. And actually that fits in with the whole, why do we care about climate change? Right. It's the difference from what we expect. And so heat waves in Phoenix are going to be different from heat waves in New York, which are going to be different than heat waves in London or in Paris or in Moscow.
Right. Because Phoenix has been astronomically determined to be 3/4 of a mile from the surface of the sun. Okay.
That makes sense.
Yes, that was science. Yes.
That science discovered that.
Yes. And so, people in Phoenix are learning to become nocturnal, and we haven't quite reached that point in New York. But, we didn't used to have that many 90-plus days, and we're having more and more. And so when we have a whole big long string of these things, we can keep track of that, and that's an indication of extreme of an extreme event associated with heat. At the kind of mid-July, we had some very dramatic heat events in Europe, in the UK, and so the UK was still cooler than Spain, but Spain was really, really, really very hot, and the UK got up to about 105 degrees Fahrenheit, which was totally unprecedented for them.
Yeah.
And you're talking about a situation there where almost nobody has air conditioning. There's no air conditioning in the subway. There's no air conditioning in most homes, and so
and of course, there they call the subway the tube. Yeah. Just to be clear,
they do.
Them a subway is the walkway under a street to get to the other side, just to get.
I was translating for you.
Oh, thank you. Okay, there I am translating back, and I shouldn't be.
By the way, neither one of those places have air conditioning, though.
No, that's the point.
That was the point.
That was the point.
Yeah.
Allow me to remind you, people, if they don't already know, that the British Isles sits farther north than the northernmost point of Maine. Mm-hmm. So if you're raking in 105 degree Fahrenheit temperatures, oh my gosh.
Yeah.
It's pretty clear how nobody's prepared for that. So like you said, it's a difference between what you're used to and what nature hands you, and that could wreak havoc on your culture, on your even civilization.
Well, on your infrastructure. I mean, they had situations where they had to stop flights out of some airports because the runway was melting. They couldn't run the trains because the rails were buckling. Like when you exceed the design specifications for anything you build, you get into trouble.
So the laying down the track say, we should do this to 110 degrees. Why? How's that going to happen? Why?
It's never happened before. Why would it happen again? Right?
Yeah.
So that this is the issue. We're seeing more of these heat waves. They're becoming more intense, and that's because of climate change. We have warmed up the planet by about 2 degrees Fahrenheit in the last century or so, but that is juicing these extremes. And so the number of times you're exceeding 90 degrees Fahrenheit, 100 degrees Fahrenheit is going up, not just like a little bit, but it's going up 4, 5, 7 times, 10 times more than it was before.
And in addition to that, what's also seemed to be happening, and I don't know if there's a science behind this, Gavin, but these weather systems seem to sit. They don't, so we used to see some extreme heat events, but they would pass over. Now they seem to park and stay. Like, oh, you know what? I'm a chill. This is nice. I like this here, and they don't go anywhere. So, is there a science behind that, or is that just is that anecdotal?
Well, and Chuck, plus we have to change the word. If they're 105 degree hotspot, they can't say I'm chilling here. You need another word for that. Yeah. So Gavin, what's up with that?
Right. So what's associated with these extreme heat is a wave event in the atmosphere, in the jet stream, and you can see this on the weather maps, right? You can see this wave kind of coming across. Each lobe of the wave is a couple of thousand miles across, and there are some patterns that happen, particularly when you have 5 of these waves going around the world, and it turns out that's a pattern that it kind of resonates a little bit, and so it wants to move this way. The jet stream is pushing it this way, and so the wave looks like it becomes a standing wave, right? So you've got it wants to go this way, but the jet stream is pushing it this way, and so it kind of like.
Wait, for people who listen only in audio, you use the word "this" going to your left and to your right. So could you choose a different word for as you're doing the disco wave with your arms? Okay.
Yes, I totally can. So Imagine a wavy, sinuous-like thing moving from kind of Europe towards the US. Meanwhile, the jet stream is pushing the other way, and so when the wave and the stream intersect, you can get some times when they don't appear to move very much. It's like you have a standing wave that can just keep things in place for longer than you might imagine. And some people call this a blocking pattern. And we've been looking at these kinds of events for many decades. And there's some indication that they may be kind of changing a little bit with climate change. But I think I would say that that's very much at the cutting edge of what we understand and what we don't understand.
Okay, so Gavin, you got London here, and I know a lot of people live in London, and it is Europe and everything, but Africa is 5 times the size of Europe. So a few cities in Europe get a high temperature. Earth is way bigger than Europe. Why does anyone give a rat's ass about? No, I mean, I don't mean to make light of it, but what I want to say is, why make global proclamations about what's happening in a couple of places in Europe just because they're complaining louder?
Because the Queen is there, and she's very fragile when it comes to high heat.
Okay, thank you, Chuck.
Sure. I think she probably has air conditioning.
And if not, there are people waving
large
fern
fans
leaves at her.
Big palm fronds.
Palm leaves are waved at her. Yes. Okay.
Oh yeah, I can speak to that. But you raise a good point. Why do we pay attention to some events and not others? Well, one of the reasons is that in the mid latitudes, so kind of that north of the Mediterranean, north of the Mexican border, we see a lot more summer variability, right? We see a lot more of these waves coming by that can move you into colder or warmer conditions. And in the tropics, you don't get that so much. Tropical climate is much more stable. The temperatures don't vary that much. You get a wet and a dry season, which makes a difference depending on what side of the equator you're on. But the temperatures during the summertime, not that really makes that much difference, are pretty stable. And so you don't get these kinds of extreme events happening. You see them, in India. We've seen some tremendous heat waves in India and Pakistan, and the rest of South Asia, and in China as well, and in Australia, like going the other way in South Africa.
And the heat waves feed these fires that we've all been hearing about?
Right. So heat leads to a lot of different things, right? So first of all, you dry out, right? So your soil moisture evaporates, right? So everything gets drier. As things get drier, they become more flammable. And so we see situations where, grass that would normally never burn suddenly is flammable. And we're seeing lots of cases where, seemingly, inadvertent sparks or accidents are now, instead of just like dying out and being put out, are leading to large configurations. And so, London, for instance, had after the day after the maximum heat had its biggest fire day since the Second World War. And those are obviously 2 different causes.
Yes, I would hope so. Yes,
but they had large scale fires, like taking out city blocks that people had just never seen before.
So if try to help me out here, because I'm sure people are thinking this. You're telling me we've increased 2 degrees in the last century or so, basically the era of the modern industrial revolution. And yet, London is not 2 degrees warmer than its average. It's way higher than its average. So how does 2 degrees warmer on Earth translate into 10, 20, 30 degrees higher than average temperatures anywhere on Earth?
Okay, so let's break that down a little bit. So the 2 degrees that people talk about that I just mentioned is the global average change, right? But you have to remember that the globe is not warming evenly. It's warming more on land than in the ocean. It's warming more in the north than in the south, and it's warming most of all in places like the Arctic. So the changes in New York or in London or in Paris are more than the 2 degrees Fahrenheit that we're talking about in the global mean. So they're about, you know, maybe 1.5, 2 times that. So maybe 4 degrees Fahrenheit, 5 degrees Fahrenheit.
Okay, so maybe you should change the messaging. It's not what the average over the whole world is, because if it's a huge range in the manifestation, if that average is an average over a wide range of data, a wide range of values, then why not give the average increase at this latitude? We're at the same latitude as Madrid or right through. New York City. Yeah. There and what the change is at Maine and in the Arctic. Why not give those numbers?
We do, right? So the Arctic is.
No, you don't. I've not heard you to give that. Okay.
I'm gonna give it to you. So the average change in the Arctic is about 4 times the global mean.
Well, no, now how did Chuck?
So now
Chuck,
listen. Here's
Chuck,
the problem.
have you heard anybody say that, Chuck?
No,
Chuck.
I'm gonna tell you. Here's the problem, Gavin. So as a scientist, when you look at incremental change, you're able to understand that. People are not. If you tell me it's 2 degrees warmer in this room than it is in the other room, that means nothing to me.
It means you don't give a rat's ass.
I don't care. What you need
You're not adjusting the thermostat for
right,
that.
I'm not. What you guys need is a scale that registers in the human psyche. So in one part of the world, it's, oh my God, hot. Okay. And if we keep going, it gets to God damn, right?
Okay.
Well, let me bring out this scale that I prepared earlier.
He's trying to stop you there, Chuck, because there's no coming back from that.
You know where it's going. You know where it's going from there.
All right, Gavin.
So you're absolutely right. You know, we're talking about numbers that really don't mean very much to people in their everyday lives, and so, quite frankly, I don't like talking about these numbers. I don't like talking about 2 degrees, 1.5 degrees, 4 degrees. They are very hard to conceptualize because people's experience of temperature in their local environments during a day, over a season, is very different to the planet's experience of temperature. And so one of the things that I like to bring up is what kind of temperatures has the planet seen over its history? And one great example is about 20,000 years ago, we were in the middle of the Ice Age. And you know where you guys are sitting now was underneath hundreds of meters of ice. The glaciers extended from the Arctic Ocean to Prospect Park in Brooklyn. They covered almost all of North America. There's something similar happening in the UK. There was enough.
And by the way, Gavin, as a kid, I remember we took a tour of Central Park right in the middle of Manhattan,
That's right.
And there were rock escarpments that were identified as having glacial scarring.
Striations.
Yeah, striations, right.
Yes.
And I'm a kid, right? I'm thinking, glacier? What's a glacier doing here? Glacier?
It was there.
Yeah, no, I remember the mental adjustments I had to make to embrace what was going on.
Right.
But go on.
So the Ice Age was a radically different climate, right? So, you know, where we have forests and trees, and it was ice. And then for hundreds of miles further south, it was tundra. The fauna is different. The ecosphere is different. Sea level is different. And do you know what the global temperature change was?
Between then and now?
Between then and, say, the pre-industrial.
Right, pre-industrial.
Okay, how much?
It was about 8 or 9 degrees Fahrenheit.
Okay.
Gotcha.
Right?
All
so
right. That's helpful. I can use that. I can use that.
Yeah. So what I like to do is let's call that an Ice Age unit, right? Uh-huh. So that's a big change for the planet.
Right.
And if you go from where we were to the Ice Age, that's one Ice Age unit. And now what we've done since the beginning of the Industrial Revolution is we've gone up about 1/4 to 1/5 of an Ice Age unit. Okay. And where we might be heading could be a whole ice age unit in the other direction. Right. And so we think, oh, these are small numbers, but they're not small to the planet. The planet notices these things. The planet feels these changes in the ecosystems, in the ice, in the temperature, and in the extremes.
Okay,
and
Gavin, this is very helpful.
That's where we come back to what's happening now.
Okay.
We're seeing the impacts of these things in the extremes because if you can imagine, a bell curve, right? And we're moving the middle of that bell curve a little bit to the warmer conditions by, a couple of degrees. But the things that are changing the most are out at the ends, are out at the very warmest temperatures or at the very coldest temperatures.
So if you're in the middle of the bell curve, you don't notice it, but on the extremes, oh my gosh, it's the extreme. Right. Okay.
Right. And it's the extremes that make the impact, right?
Yes.
Nobody cares if a mediocre day is 2 degrees, 4 degrees, 5 degrees warmer than a previous mediocre day. But when you get to 100 degrees plus, every additional degree makes a difference. It makes a difference to how much the rails are going to buckle. It makes a difference to how much the airport is going to melt. It makes a difference to how much energy.
We can't land because the airport melted.
That's great. So, I know we got to wrap up, but I got to ask you this, Gavin, because the things that you're talking about are infrastructure, and that's a big deal because that costs people a lot of money, costs governments a lot of money and resources. But it still doesn't affect people's psyche because they look at it like, well, that's why I pay taxes, and that's what the government is for. So what I'm going to know is, when does it get to a place where we exact a personal cost, like where your health is really in danger? Like there is a heat limit when you look at humidity versus temperature that human beings cannot exist.
There is. I mean, for places like the UK, we're quite a ways from that. Places like Dubai and India, we're a little bit closer. And in fact, we're going to see places kind of hitting those limits, mostly in the tropics, not in these kind of heat wave situations in the mid latitudes. Mainly because the humidity is higher in the tropics. But we already feel the impact, the health impacts of heat. Every time there's an event like this in the UK, they're anticipating perhaps 1,000 excess deaths because of the 2-day heat wave. We see it when we have heat waves in the US. There's a big increase in mortality. Unfortunately, mostly elderly people.
Well, they lived a good life.
And they're fine. Or small children being trapped in cars.
Right.
You're right. I read a great article just yesterday. Believe it or not, people, heat-related events kill more people in the United States than any other weather event. You take all the other weather events, and heat is the one that does it more.
Heat's the one. Okay, all right.
Yeah.
So, well, guys, we got to land.
Seeing those impacts.
We got to land this plane on our melting airport. So, Gavin, thanks for on short notice coming in to do this because we've just been seeing these reports of heat waves all around the world, and we wanted to get some climate change perspective on it, which you duly provided. So I know you're on holiday right now. Thanks for dialing into this. And it's always good to have you in arm's reach. We feel privileged that you're there for us. Chuck, I know you're a climate enthusiast.
Big time.
And fundraisers that you do.
Yep.
And you host. And it's great to know that you're walking the walk, not just talking the talk.
Absolutely.
All right. I'm Neil deGrasse Tyson. This has been a Heatwave Explainer on StarTalk. Keep looking up.